In this video, we're going to talk about how do we create a frequency distribution from a data set. So let's begin. So if we have a data set, and we're going to use the data set below, which is daily commute times in LA, to construct a frequency distribution, we first have to figure out how many classes do we want. And usually, if this is a My Math Lab problem that's going to be given to you, if this is a real life problem, you may have to look at the data and kind of gauge how many classes do I want. Do I want 5 classes? Do I want 7? You want to be able to have enough classes so that you can see what the shape of this distribution is going to look like. Too many classes and it may just be overwhelming. Too few classes, you may not get a good idea of the shape. So once you determine that, you can figure out the class width. Class width is going to be the biggest value minus the smallest value divided by how many classes you have. And then we're going to identify what those classes are. We're going to use that smallest data value as that first lower class limit. And then we're just going to add our class width to get our second class, where it starts, the lower class limit for it, and then where the third class is going to start, and so on. Once we know all the lower class limits, we'll be able to find the upper class limits easily. And then we've got to start putting that data into a frequency distribution. And I like to do that using a tally column. So let's do that. In this example, we are using daily commute times in LA. These times are in minutes. And we want to use 7 classes. So our class width is going to be the largest value minus the smallest value divided by the number of classes. So if we look at this data set, 90 is the biggest data value that I see. 5 is the smallest one that I see. So I'm going to have 90 minus 5, and I'm dividing by 7 because I want 7 classes. So I've got 85 divided by 7. And I'm just pulling the calculator up. 85 divided by 7 is 12.14. We don't want to use 0.14, so I'm going to round up. I'm going to go with 13. So when I look at my classes, I'm going to do a tally column, and then we'll talk about the frequency. My first class is going to start at 5. That is my smallest value. And I'm just going to add 13 to that. 5 plus 13 is 18. $18 plus 13 is 31. 31 plus 13 is 44. Add 13 again to get 57. Add 13 again to get 70. 13 again gives me 83. And if I did 13 again, I would get 96. But I don't need to go up that high because remember, my biggest number is 90. So that's going to put me beyond my data. Okay, I'm going to leave it there just temporarily. Now, we've got the lower class bounds. Let's talk about the upper class bounds. Okay, if this second class starts at 18, then the first one has to stop at 17. If this one starts at 31, this one has to go to 30. So you can use that lower class limit for the next class to figure out what the cutoff point would be for the class behind it. If this starts at 44, this has to go to 43. If this starts at 57, this has to go to 56. If this has to go to 70, then this has to stop at 69. If this has to go to 83, then that means this cuts off at 82. And if this would have gone to 96, then I would stop this at 95. Now remember, we don't need that 96. That's beyond what our data has. So I'm just going to draw my table in here. So there's my distribution setup. So now we are going to utilize that tally column. And here's the way I like to do this. And change my color. I'm going to go down each of the columns. So that first number is 18. 18 falls into this category. I'm just going to put a tally mark there. 20 falls into the same category. 10 falls into the first category. So I have used that first column. Second column, I have a 25. 45 and 45. Third column, 45, I'm going to put a tally mark there. 30, I'm going to put a tally mark there, and then 30. That gives me 5 there. So once I get the 5, I draw a line like that. That way I know every group of those is a group of 5. Just makes it easier for me to count. Next column, 75, 60, and 15. Then I have 60, 30, and 25. 40, 20, 25, 25, 15, 5, 8, 30, 90, 50, 60, 30, 10, 30, 15, 10, 15, 60, 30, 35, 20, 15, 40, 60, 25, 5, 30, 50, 30, 25, 20, 40, 25, and then 30, 20. 30, oops. 30, 20. So let's count how many we have from each. We have 5, 10, 11, 10, 23, 4, 5, 5, 1, and 1. So our frequency distribution here would look like that. So if we wanted to clean this up, we could rewrite it and we would just ignore that tally column.